Hello there and welcome to this video series on control systems. In the previous video, we have considered electrical circuit elements, resistance, inductance and capacitance, and we have seen what will be their contribution when we take Laplace transform with zero initial conditions. Then we have seen how we can combine them, impose a system level constraint to obtain the transfer function of RLC series circuit. After watching this video, you'll perhaps be able to write equations and derive TF of simple RLC circuits. With that, we'll see an example. Consider this circuit and supplied with a voltage V in of T. Because the same current flows through R, L and C, we say that they are in series. Let us say V in of T is the input, VO of T is the output, and we want to derive the transfer function output over input, that is VO of S divided by VI of S. To do that, we will consider loop current as shown here. This current I of T flowing through these three R, L and C, and apply Kirchhoff's voltage law. Note that resistance contributes the term R, inductance contributes the term L times S, this capacitance contributes 1 by CS. With that in mind, we write the equation total voltage drop is voltage supplied is equal to drop across resistance plus drop across inductance plus drop across capacitance. And we write this equation 1. We take Laplace transform on either side of this equal to sign in the equation to get, we get this equation in Laplace domain. R times capital I of S, Ls times I of S, 1 over Cs I of S. So we collect all the terms having I of S onto one side and Vi and S on other side. Note, we are using zero initial conditions. Notice that the output VO of T is the drop across the capacitor, and it may be written as VO of T is 1 by C integral 0 to T I of tau, because we know capacitor accumulates charge as summation of current. So taking Laplace transforms, we have VO of S is 1 over Cs Is again with zero initial conditions. If you go back and carefully look at equations 2 and 3, it becomes apparent in a second to see how we can eliminate the intermediate variable I of S to get the transfer function VO of S divided by V in of S. We want VO of S and V in of S in the picture. We want to eliminate this I of S. That we can do simply by dividing equation 2 with 3. And we see that this is the transfer function of the system with input as Vi in, output as VO. Thus, in summary, we say deriving transfer function of a system involves writing equations for individual elements using physical principles, then take Laplace transform with zero initial conditions, impose system level constraints, and eliminate intermediate variables and retain only output and input. The ratio gives you transfer function. This RLC system we have seen in the example is a second order system. It has two storage elements, the inductance and capacitance. And that's all we have for now. Have a great day.